Hello everyone, in this video we are going to discuss the solution for find the smallest divisor given a threshold. So let's see what this question is all about. Alright, so let's study the question first, then we will move on to how we can solve this, right? So we have been given an array of integer nums. So this is my integer of array. Oh sorry, array of integer, right? And integer threshold. Yeah, this is my threshold. And we need to choose a positive integer divisor and divide all the array by it, not the array by it, but the element of the array. Okay, and sum the divisions result. Sum the divisions result. What is the result of the division? Quotient. Okay, so instead of this you can say sum uh, of quotient. ठीक है. Okay, find the smallest divisor. So I need to find the small divisor such that this sum of quotient is less than a threshold, less than or equal to, sorry. Okay, so each result of division is rounded to nearest integer greater than or equal to element. For example, 7 divided by 3 equal to 3, meaning that the quotient should be rounded up to the seal value of the quotient. So 7 divided by 3, what is the value? 2.33 something. If we will do the seal, what we'll get? 3, right? So this is what we need. That's how we are going to find the result of the quotient. Okay, so have you studied the quotient, previous quotient well? Let's find out. Okay, so in that question what we were doing, we were given Coco was having trouble eating banana, and we need to find the smallest speed for her so that she can eat all the banana in the pile before the guards can come and catch her in the act. Okay, so in that question, okay, let's reference that question later on. Let's try to solve this question now. Okay, so let's say I want to calculate the divisor. So let's start with 0. Let's start with 0. Is division by 0 possible? If you need to find that answer, go and search if you can divide by 0 or not. But I'm going to start my division from 1 because I know division by 0 is not possible. You can try to do that and Java is going to give you error. Alright. Java and C++ and all the other languages. Right? So it doesn't matter what language you choose. This is going to always give you error that division by 0 is not possible. Okay, so let's start with 1. I will start with 1 by 1, 1 by 2, 2 by 1, 1, 5, 9 is for 1. Sum of quotient is equal to 10, 17. So 1 can be my answer. Start with 2, 1 plus 1 plus 3 plus 5. Okay, so 8 and 10. So it's not possible. Let's increase our divisor. So 3, 1, 1 and 1. No, not 1, 2 and 3. Plus equals 5, 7. It is still greater than the threshold. Let's take 4. Okay, 1 plus 1 plus 2 plus 3. Still 7. Let's start with 5. 1 plus 1 plus 1 and plus 2. Okay, so that's it. Add it, we get 5, which is less than threshold. But what we are given, the result of mentioned is less than equal to threshold. So this is less than threshold but not equal to threshold. But is there any integer remaining that can give me the threshold of 6? No, it is not possible. 5 is the only solution here, right? You can see as well in our sample output as well. 5 is the answer for the same array and the same threshold. Okay, so don't complain. Right. Now, if you look closely, what we are doing, we are trying to search one number among infinite numbers. We are starting from 1 and we will go till infinity. Let's write it here. 1 dot 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 infinity. We are doing something like this. We are searching something and we are going one by one towards a greater value. Isn't it the linear search algorithm? If we can use linear search algorithm, can't we use binary search here? So we can use binary search. But won't it be idiotic to start from 1 to infinity and then calculate middle and then try to search? It's going to take very long time because value for infinity is not defined. Infinity means very big value, right? This is not going to give me a very efficient solution. This is going to take much more than anything. It's going to take actually more time than what you can say infinite, not trying to find middle for the infinite value is actually possible, but we are not going to do that here. We need to reduce time as much as possible. So instead of going for infinity, we will try to find something related to my array. If I use the maximum value from here, isn't it possible to find the smallest divisor after this? Because at minimum, this will give me these values: quotient 1, quotient 1, quotient 1, and quotient 1. And minimum threshold will be 4. And even if I raise to 10, this is going to give me same result. 11, also same result. So instead of going till infinity, I will start with 9. Right? If you have watched the previous video, don't you think we are doing the same thing here that we did in the cocoa eating banana question? Yeah, we are doing same thing. First, we are finding the highest element, which is nothing but 9. Now we are going to apply binary search. From 1 to 9, let's apply binary search. Mid is 5. And we are going to check the sum of quotient made by 5. 1 plus 1 plus 1 plus 1 plus 1. Not 1, 2. And I have 5. So 5 could be my possible divisor. Okay. Now, what we were doing in that question, if we find a possible value, then what we were doing, we were trying to reduce this value. So now we are going to check from 1 till mid minus 1, which is between 1 to 4. Mid is 2. Actually, it's 2.5, but we will take 2. Right? So let's calculate with 2. 1 plus 1 plus 3 plus 5. 8, 9. It's very big. We need to reduce it. And to reduce it, what we need to do? We need to increase our mid. To reduce this, we need to increase our mid. You understand what I'm saying? So what we need to do is, we need to search in between 3 and 4. 3 and 4. Mid is going to be 3. let's compute it with 3. Now what we are going to get? 1 plus 1 plus 2 plus 3. But we are going to get 5, 6, 7. Still more than that. So now I need to increase my low again to mid plus 1. Mid was 3. So now my low value and high value will overlap over 4. Now I'm going to check for 4 because low and high equal same. So mid is also going to be the 4. So 1 plus 1 plus 2 plus 3, 5, 6, 7. 7 again, which is more. So we need to increase our low and higher. We need to search our area, but we are overlapping already. If we are going to increase our low, my low will become 5 and high will remain 4. But if you will remember in the binary search, we just stopped in this condition. We were searching only for this condition. Low is less than equal to high. Now low has become 5 and high is 4. So we are not going to search anymore. And there was only one possible solution, which was not updating. So I am going to return this 5. So that was a very pretty simple question. And if you have watched the previous question, you will find that we have done exactly the same thing in that question. In place of this array, I had files array, which was storing the number of banana in each pile. Okay, and instead of threshold, I had number of R, which was denoting the number of R's for which the guards are gone. And I was trying to find some speed so that Coco can eat all the banana at a very slow pace so that she can enjoy eating those bananas. And as we discussed earlier, she was a banana lover. So she actually wants to eat banana at very slow pace. So we need to decrease the speed as much as possible, but letting her eat all the bananas. Alright. So we are doing the same thing here, and when I will code, you will actually understand why I said this. And if you haven't watched that video, after I have written the code, I will actually suggest you to go and watch it. Okay, and why I will do that, I will tell you in the coding part. So let's start the coding part now. So the solution is going to be the same as our Coco eating banana. So let's see its solution, or rather than I should say solution code. So similarly, what we were doing earlier in the Coco eating banana, we are going to do the same thing. And like now we have learned, we are first going to find the max in the number of integers that we have been given. Okay, so max, let's say starting is 0, and now I'm going to run my loop for I equal to 0, I less than nums dot size I plus plus. Now I'm going to compare mx with nums I, so that I will be able to find the maximum value in the nums. Alright. Now after this, what we were doing a binary search for low equal to 0. No, low should not be equal to 0, right? We already discussed division by 0 is not possible. So instead of starting with 0, we are going to start with 1. Right. Now high should be equal to mx, and one thing what we were doing was finding the divisor. So let's create a divisor. Okay, so this is my divisor. Let's start it with 0. It doesn't matter because we are going to change our divisor with mid when we are going through our loop. Okay, so low should be less than equal to high. And one more thing, I said that divisor equal to 0 is not going to give me any trouble, because in the question itself we have been given there is a guaranteed answer. Okay, so that's why I have written 0 here. Okay, so now in the for loop, first thing we need to calculate is the mid or the divisor, right? So mid could be taken as low plus high divided by 2. Hmm. Is it so? If you have watched my previous video, you will know this should not be the answer because of overflow problem. And if you haven't watched that video, then I will suggest to see that video once again, or maybe just see the solution part. You will find the same thing that I said in that video, and which is that it is going to give me a overflow problem. Overflow of what? Overflow, integer overflow problem. Suppose my maximum element in my nums array is the value of maximum integer possible, and I'm trying to add some value to it, low. And we know that all the numbers in my array is positive, so this is definitely going to give me some trouble, right? Because high is at the end and I'm trying to add something to it, so high is going to overflow. Because of this, like I did in my previous video, I'm going to calculate my mid through this mean. Okay, low plus high minus low divided by 2, and this is how I'm going to calculate the mid. And I have to check if the mid I have discovered is possible, is possible ideally. And what is possible? Is it possible to have the sum of quotient by this divisor to be less than or equal to the threshold? That's what we need to find from this function. So we are going to use some abstraction and say that this is going to give me something, and I'm going to pass my nums and all the array. Okay, so what I need to pass on mid, the value for which is it is going to decide if the quotients are sum of quotients is less than the threshold. Now I need to give it the threshold also, because if I don't give the threshold to this function, this function is going to tell me if it is possible or not. Okay, so after this, if it is possible, then I will write divisor equal mid, and I'm going to start decreasing this divisor. So for that I need to write high equals mid minus 1, so that I could check if there's anything less than the mid which can do the same thing. Okay, else if I'm not able to find anything in that area, I need to increase my mid. So for that I need to do low plus low equals mid plus 1. That's it. And after this I'm just going to return the divisor. That's it. My function for find smallest divisor is completed. But now I have to write this function. Okay, so let's complete this function also. It's going to return me a boolean value saying is it possible or not. What is possible or not? Simply, is it possible to have the sum of all the quotient by the mid that we have been given is less than or equal to the threshold. So our mid is int and threshold is also int. That's it. We are done here. Now we need to calculate the sum of the quotients. So let's start sum with 0 for int I equal 0, I less than nums dot size and I plus plus. That's it. Okay, now sum plus equal nums I divided by mid, and after this I need to check return if my sum is less than equal to my threshold. If this is true, then it is possible. This could be a possible divisor. Okay, if this is not possible, then I will return false. Alright. So is it the way to calculate a quotient in this question? No, it is not. I told you earlier that we are finding seal here. Okay, so I need to add seal. But seal is not going to be calculated like this because both of these number are integer. So I have to convert it into a floating point value. So for this 1.0 multiplied, and that's it. There is some mistake. In 18 I have made some mistake. mx I, okay, semicolon. Right. So we have got a successful submission for our sample input. So submit it. So it passed all 3 test cases, which means that we have the same result that we wanted, or the same function that we needed to write. Okay then. Now, if you have seen my previous video, you will find that I have written the same thing. Here, here, here. Entire thing is same. Just I have changed the nums files. I used piles in place of nums in the last question, speed in place of mid, and hours in place of the threshold. I was using nums piles here and speed here and R here, and rest of the code is entirely same. So isn't it possible that I have written the same code? Yes, I have written the same code, and you will be surprised that the question we have right now is same. But you shouldn't be surprised because I told you earlier that both of the question are entirely same, and like in the last question, our time complexity is going to be n log n. I'm doing n times work here, n times work here, and n log n time work here because while loop is going to run in log n, and it is calling a function which runs in n. So n log n. So overall time complexity is going to be O of n log n. I haven't used any extra space. So space complexity is constant, O of 1, and that's it. This is entirely the same solution that was for the cocoa eating banana. So what we find here is we have just changed the word and the concept remained entirely same. See, if you will try to compare my old code that I have done in my last question, you will find that this I have just replaced these 3 words only, and rest of the thing is entirely same. Okay, so if you don't believe me, go and watch cocoa eating banana video and you can compare it line by line. Okay, So that's all for this video, and I will see you in the next video.